Hello everyone and welcome to our Automated Big Data Testing Without Writing Code webinar. My name is Bill Hayduck. I'm the CEO of RTTS and I'm here with Jeff Picardsley, who's the Chief Architect for QuerySurge, which is RTTS's software division. So without taking too much time, we're going to get going on our webinar. So our presentation topics, as you can see, is we're going to go over a brief intro into how we test the data warehouse, and then we're going to get into the meat of it, which is testing big data. We'll talk about current testing strategies that are being used right now, and then a little bit about QuerySurge, which is our solution around testing big data, and then Jeff's going to do a demo of QuerySurge. So just a blurb about RTTS, which is the parent company of QuerySurge. We're the leading provider of software and data quality for critical business systems. We're founded in 1996. Our headquarters are in New York City. We've had over 600 customers, and we're strategic partners with pretty much everyone in the big data space. Teradata, Hortonworks, Microsoft, HP, Cloudera, Oracle, IBM, and Amazon. So let's look at some quotes from the experts out there regarding data quality. First one's from Analysts firm IDG. They said that 70% of enterprises have either deployed or are planning to deploy big data projects and programs this year. From Information Week, 46% of companies cite data quality as a barrier for adopting business intelligence products. From Analyst firm Gartner, poor data quality is a primary reason for 40% of all business initiatives failing to achieve their targeted benefits. All right, so obviously, it's become critical all the way up to the executive office and the C-level people because they're now using business intelligence and analytics to make critical business decisions. And their assumption is that the underlying data is fine. According to our friends at Gartner, they say that the average organization loses about $14 million annually through poor data quality. And here's what the underlying data architecture may look like. And there's a lot of potential problem areas from the source data through the big data that the source data is being pulled into, through an ETL process into the data warehouse, there's certain data marts, and into the business intelligence software that the C-level people are making decisions based on. So obviously these are really critical areas that need to be taken care of and the data quality has to be validated. So let's take a brief look at data warehouse testing. Again, some quotes from about the marketplace. From Consulting Specialist 451, the data warehousing market has a compound annual growth rate of 11.5%. It's supposed to reach $13.2 billion in revenue. So that's really growing rapidly. Key vendors in the space, according to Gartner, are the same ones that we partner up with: Teradata, Microsoft, Oracle, IBM, HP, SAP, and then 1010 Data and Amazon. So let's look at your typical data warehouse ETL process. So typically what happens is you have your source data, the data is extracted, transformed in some cases, and then loaded into your data warehouse. So when testing it, the recommended fundamental testing strategy is to test at every single point in the system, from sources all the way back, all the way forward to the BI tool. So that will provide you with rapid localization. So what you want to do is test in between each leg so you can identify exactly what's causing any data problems if there are any. Okay, on the big data testing side, again, a quote from Analyst firm IDC, the big data technology and services market is going to grow at a compound rate of 26%. To $41 billion through 2018, which is 6 times the growth rate of the overall IT market. So this is obviously one of the hottest growing markets in the IT industry. So let's look at some of our key vendors on the Hadoop side. Again, Microsoft, Cloudera, Amazon, Hortonworks, MapR, and IBM. And on the NoSQL side, Amazon again, MongoDB, Oracle, MapR, DataStax, Cloud, and then Cassandra. Again, basic Hadoop architecture, you have your MapReduce that does the processing part, and your Hadoop distributed file system, which stores the data. And then this can be set up in nodes for scaling from 1 to 1,000 nodes. And then Hive is the part where your testers or anybody doing data quality is going to interact. Hive is a mechanism that provides a SQL-like language called HiveQL or HQL that interacts with the HDFS files. So we're going to look at two use cases. The first one is Hadoop into a data warehouse, and the second one is a NoSQL data store into Hadoop into a data warehouse. So in the first one, again, your recommended functional test strategy is testing at every entry point so you can localize any data issues. So from source to Hadoop to target data warehouse to the business intelligence front end. And the second use case is MongoDB. As source to ingestion by MongoDB, MongoDB to Hadoop, Hadoop to your traditional data warehousing software, and then from that to your BI and reporting analytics software. Again, rapid localization at every test entry point will allow you to identify exactly where the data problems are. So let's look at the two main data testing strategies out there. The first one we like to call stare and compare. It's also known as sampling. And the second one's minus queries. So with stare and compare, the process flow is typically whoever's doing the testing will review the mapping document for the business rows to see where the data is being mapped and flowed from one point to another, and any data movements. And then they'll write SQL in their SQL tests in their favorite SQL editor, whether it be Toad or Squirrel or whatever editor comes with their database or data warehouse. And then execute two tests, one at the source and one at the target. Dump the results to two Excel files. And then that's where stare and compare comes in. So basically, looking at all this data, one file from the source, one from the target, which makes it really, really difficult to visually compare all these data sets. Usually less than 1% of data is compared, and that's why they call it sampling. We like to call it stare and compare because if you look at two Excel spreadsheets of any kind of size, you're going to go blind. So just as an example, we have a customer right now that has a single test with 100 million rows and 200 columns, which are 20 billion data sets. Think of how hard that would be to compare in two Excel spreadsheets. That particular client has over 7,000 total tests, although this is the largest, but lots of them in the tens of millions of rows and 10 to 200 columns. So very, very difficult to do manually. The other strategy is minus queries. And what minus queries does is it subtracts one result set from another result set to show the difference, and you do it twice. You do source file minus source result set minus target result set, and then target result set minus source result set, and you see what rows are left over, and you do a comparison, and hopefully this will show you any differences. So again, write two minus queries in your favorite SQL editor, execute minus queries twice. Here's an example of it. Table 1 has a data set, table 2 has a data set. The first example is minus query number 1, table 1 minus table 2, and then minus query number 2, table 2 minus table 1. You see the leftover result sets. Hopefully this will show you any kind of issues. But there's inherent issues with minus queries. The results might not be accurate when dealing with duplicate rows of data. There's no historical data, so if you're in a regulatory industry or you have audit requirements, you're not going to have any history here for reporting on it. Also, processing of minus queries will put a lot of pressure on your target data warehouse or big data store because that's where the processing is being done. And there's also a propensity for false positives. So all of these produce some issues when dealing with minus queries. So in both data testing strategies, there's a fundamental issue that's not even talked about with those, and that's the issue that it's assumed that all team members can understand and write either SQL or HQL code, which is not the case. So now let's look at QuerySurge, which is our big data testing solution. QuerySurge is, as we like to say, is a collaborative big data solution that finds bad data and provides a holistic view into your data's health. So QuerySurge was originally built around data warehouse testing, but about 3 years ago, we incorporated big data testing into it. And our clients have found other interesting ways to use the solution. Some have used it for data interface testing, which works really well with. which is testing your ERPs such as SAP or PeopleSoft with all the external feeds coming in. So it tests those interfaces really well for data migration testing and for data upgrade testing. But we're going to focus now on big data testing. Some of the advantages that QuerySurge brings inherently is you can create tests easily with no programming. That's one of the topics of our webinar. So you can create tests visually, which will ensure minimal time and effort to create these tests and obtain results very easily. You can also verify more data and do it quickly. You can verify up to 100% of all data, and the comparisons are done up to 1,000 times faster than stare and compare or minus queries. You can automate the entire testing cycle, meaning you can automate the kickoff of the test runs themselves, the comparisons, and then have auto-emailed results sent to everyone on the team. You can test across a lot of different platforms, not only your data warehouse and Hadoop installs, but also all your NoSQL data stores, any database, flat file, or XML. Also, it integrates for continuous delivery, so it falls into your DevOps strategy very well. So it integrates with most build software, ETL software, and QA management software out there. So you can kick it off from them and automate the entire process. And it's also a great collaboration tool, so you can collaborate via our data health dashboard, our shared tests, and auto-emailed reports. And then as a collaboration solution, not only can testers use it for functional regression testing, which is what our original target is, but also developers can use it for unit testing. Managers can use it for oversight and result analysis. Operations teams can use it for daily monitoring of their tests. And data analysts can use it for reviewing and analyzing data. A little bit about the architecture of QuerySurge. QuerySurge has a web-based controller, has a server, and has agents very similar to like an HP load runner setup, where it's distributed workload. It can install on either Linux or Windows. You can put it in the cloud or on a VM machine or any virtual machine. It can connect to, again, everything you see here. We haven't included everything. I can't fit them on the screen. But pretty much any JDB compliant data store it can connect to. How QuerySurge works is it connects to your data sources, and it pulls data from your sources and from your target data store, brings them back into our database. It not only compares them very quickly, but it compresses them to 90%, reduces it by 90% to 10% of the actual data, so you can store lots of data. It generates reports, the audit trails, and the auto emails. Let's take a look at the QuerySurge modules. There's 6 of them. The first one being the query wizards that allow you to write tests visually without writing any code at all. The second one is should you need to create custom tests, our design library allows you to write custom SQL. We have scheduling, which is very flexible. You can launch tests now every Wednesday at 11 o'clock or after an event like an ETL process ends. We have a runtime dashboard where you can view execution in real time. We have deep dive reports that you can view and share and export in lots of different formats. And then we have our data health dashboard that sits on top of everything and allows you to view the health of your data in real time. Here's some quick snapshots. Jeff will go into more details on this regarding QuerySurge. On the upper left is our design library where someone can write custom query pairs. This is great for team members that are skilled in SQL or HQL. Bottom right is our scheduler, where you can build groups of query pairs and schedule runs to happen whenever you want to. Upper left is our runtime dashboard, where you can view the real-time execution. Bottom right is our deep dive reporting, which allows you to examine your test results. Something new we came out with early in 2015 was our test management connectors. We've integrated it with the leading test management solutions, so now QuerySurge integrates with HP ALM and some older versions of the Quality Center solution. Also, it integrates with Microsoft Team Foundation Server and IBM Rational Quality Manager. And by integration, what we mean is you can actually store your tests in these test management solutions. You can execute QuerySurge from them, and then all the outcome results, pass or fail, will be reported back into your favorite test management solution, and it'll have links in the test management solution that allow you to drill directly into all the underlying data so you can see exactly what failed. We've also built it, as I said before, for continuous delivery and continuous integration to round out your DevOps strategy. So QuerySurge can be launched from pretty much any data integration ETL solution, including some of the biggest ones out there like Informatica Power Center, IBM DataStage, and all the other ETL solutions that are out there. They can kick off QuerySurge when they're done with their ETL process automatically, and QuerySurge will run unattended, execute all the tests, provide all the results, and bring it back to your favorite test management solution. The same thing on the automated build solution, and also on the test management solution. If you want to run everything from right out of your test management solution, you can have that automated, kick off QuerySurge unattended, run, and then bring all the results back to your test management solution and have auto-emailed reports sent to everybody on the team or whoever you select to receive those reports on the team. Okay, so let's look at the way you can test big data visually. We came out recently with in July with our query wizards, which make data testing really easy. There's no programming involved. So we did a poll before we did this of data experts, and what we wanted to know from the big data experts, data warehouse architects, ETL architects, was the answer to a question. And our question was, what % of columns in your projects have no transformations at all? So the response to consensus answer we got was about 80% of data columns have no transformation at all. And this is really important. This is important because when we put out the query wizards, that basically means that you can perform about 80% of all your tests without writing any SQL. So you can select the table on the source, the table on the target. You could select the specific columns on the source and target, match them up, and do it visually and do it very quickly. And about 80% of your tests will be done without writing a line of code. So the query wizards automatically generate, whether it's be SQL code or HQL code, depending on which architecture you're testing against. This opens up testing not only to seasoned SQL testers who this will speed up the process, but also to novice and non-technical team members to be able to participate and help quickly with writing these tests and move the process along and do it all visually. And as I said before, it'll speed up testing for skilled SQL coders. And this provides a huge ROI. One of our clients calculated at about 1,300% ROI on an annual basis. So we have 3 types of comparisons built into the query wizards. The first one is a column level compare. It's great for big data stores and data warehouses with transformations, with some transformations. We have a table level comparison. This you can compare many tables. It's great for data migrations and database upgrades with no transformations. And then we have a row count compare, which you can use with anything to verify the rows on your source versus your target. The query wizards also come with features for filtering and sorting. Filtering, also known as a where clause, and sorting, known as an order by clause. All this done visually. So let's look at the column compare wizard briefly. Again, you could test up to about 80% of your data store without writing any SQL. Great for big data and data warehouses. Great for novice or non-technical people to get the bulk of the testing done without writing any code. And for an experienced user, it's going to save a lot of time. So when they do have to write custom SQL, they can focus on that instead of on the easy grunt tasks that can be done visually. The column compare wizard, we're going to show an example here where you pick your source and you pick your target, and then you pick your comparison type, which is your column level comparison. And then you're going to select the tables and then the columns that you want to match up. And then it's going to auto-generate the SQL, and you're going to put in your filter and your sort right here. Very easy to do. Your table compare wizard verifies data loads when no transformations occur. Great for data migrations and upgrades. The value added is there's no coding needed for your novices, and it saves time for your experienced user. And you can compare lots and lots of tables at the same time very quickly. Your row count compare, again, used for pretty much anything, whether it be big data, data warehouse, data migrations. No coding needed for a novice. It works out very well. For an experienced user, it saves a lot of time. Just I want to mention before Jeff gets into the demo that on the training and consulting side, we have training courses on our parent site, RTTS, that has 4 different courses wrapped around data warehouse testing using QuerySurge. And we also have 2 courses wrapped around big data testing, specifically with examples of Hadoop and labs with Hadoop and using QuerySurge. And then we have consulting, where we have a Jumpstart 2-week program to get people up to speed very quickly in the strategy of doing big data testing and implementation. We also offer stack augmentation and outsourcing. And if you want to play around with QuerySurge, we have 3 different trials that we offer. The first one is a trial in the cloud. You can just throw your email out there. It could even be a Gmail. It only works with our data. We have a built-in tutorial. It takes about an hour. You'll be an expert in about an hour going through this trial. The other one is our downloaded trial of QuerySurge. Not only does it include our self-learning tutorial, but it also includes the ability for you to connect to your data and test on that. And you have 15 days to do that. And if you want to do a proof of concept with our team, you contact us and our team will meet with you, help you set up, and walk you through and meet with you periodically on testing your data with QuerySurge visually and through custom SQL. So feel free to try any of those and let us know if you want to do the proof of concept. And lastly, I'm going to turn it over to Jeff, who's going to show you a demo of big data and doing it visually.
Thanks, Bill. Let's log into QuerySurge and take a tour. And when you come into QuerySurge, the first thing that you see is our widgets dashboard. The widgets dashboard is composed of a series of widgets chosen by the user to focus in on different parts of the project. So, for example, just to give you a flavor of this, if you look in the upper right, you'll see that we have a widget that shows us the query pairs, that's QuerySurge's term for a test, that are created over time by one of the users on the project. So if I'm a manager, maybe I'll have a widget for each user on the project that will help me track their query pair creation. Or perhaps if I'm just a team member, we'll have widgets for each other so that we can keep track of each other's progress. Another example would be the lower left, where we can see our test outcomes. So if we want to focus on the outcomes of our tests as a team, we can see them all in the desired widget. Let me direct your attention to the QuerySurge launcher. That's the widget in the upper left. That's a special widget because it gives you access to the whole QuerySurge workflow, from design, where you craft your tests, to scheduling, where you're going to make up schedules of various sorts for your executions, to the run dashboard, which is a real-time dashboard that gives you access to the data as it's flowing back into QuerySurge, to reporting, so that you can generate your formal reports. And lastly, of course, we've got administration there, which is not part of the daily workflow, but it's where you do all the standard administrative tasks like set up users, set up connections, manage data, and so forth. Let's jump in and let's talk about some tests. And you can see we can access the design tests from the grid, or we can also access from the tree view. And if I go in and open up one of these tests, what we call a query pair, you can see that it's composed of a source query and a target query. These are designed to bring back data by you from 2 points in your architecture for comparison, and testing leg by leg or jump by jump, however you want to structure it, between any 2 pairs of points in your architecture is how QuerySurge works, and how you get to the high level of confidence in your ETL or your big data deployments that you want to get to before you come to production. Now, I should stress here, first off, about this query pair, that you can use pretty much any kind of technology in these things that you want to, anything that's JDBC compliant. I'll just quickly call out a number of the technologies that we show here. Of course, our focus today is on big data, so we have Hive here. We can also do MongoDB through a third-party driver, another big data illustration. In addition to that, all of the standard well-established big data providers in the marketplace are represented here. So, for example, we can do the IBM products, either DB2 or Netezza. We can do HP's Vertica, we can do Teradata and, of course, Aster. We can do the Oracle products. So I've got Oracle listed here in some of its versions, as well as Exadata. And in addition to those, of course, we've got some of the older technologies represented here. The possibility of doing Excel or fixed width flat files or delimited flat files is also part of QuerySurge. Those are still important components of many ETL and big data flows. In addition to that, of course, we can handle XMLs. So lots of good technology choices. Pretty much anything you've got, we should be able to handle. And the other thing I need to stress here is that your choices for connections on source are identical to your choices for connection on target. So either query can be pointed in any combination, in any order, to any technology that you need to. The control of this is completely up to the user. Now let's spend a minute and talk about where query pairs come from. As was previously mentioned in the discussion, some 80% of query pairs are pass-through query pairs that really require no major transformation at all. So in order to support those, what we've come up with is the Query Wizard. And the Query Wizard is, of course, a tool that will allow users who have data knowledge and who have business rule knowledge, but don't necessarily have a great deal of SQL knowledge, to participate in creating that 80% of query pairs that are pass-throughs. And when you use the wizard, you choose two connections that are built in QuerySurge, as we just saw. You then have the choice of comparison type. We're going to stick with the column level comparison, but you also have options to do table level comparisons, which are select star queries, or just auto-generate row count comparisons, which are count star queries. Once you've made your choices, we come in and finally we choose our schema, and we can get down to business. So what we get is a listing of all of the tables on our source and our target connections. And what I'm going to do here is just do a little bit of filtering, because frequently we have lots of tables and we'll need to filter down to see what we're interested in working with. So now that I've done my filtering, I'm going to hook up two tables just by drag and drop. And immediately two things have happened when I make that connection. One is that in the lower portion of the wizard, you can see that we've generated some simple select star queries for these two tables. And in fact, if we wanted to stop here and save our work, we could do that. But we're going to move on, and the other change that occurred when I connected those two tables is how we move on, because you can see that the column relationships between source and target have now been populated, and I have the option of enhancing my query pair with specific column information. So I'm going to go ahead and do that, and I'm going to connect some of the identifiers here. And some of the data related stuff. And once I've got those connections made, you can now see that the source query and the target query in the lower left and right have been updated automatically so that they specify individual columns. What we're going to do now is come down and add some other detail to our query pair, and we're going to do some filtering. So I'm going to create a filter here, and I'm going to look for data that's above a particular number in terms of the IDs. I'm going to do that on source, and I'm going to do that on target. And we can see now that where clauses have been generated for both source and target automatically as I made those choices. I can do some other things too for source and target. For example, if I want to do some sorting, I can do that as well. For the sake of illustration, let's say we're going to do a descending sort. And you can see now that both source and target have automatically been elaborated with an order by clause conforming to the instructions that we've chosen for this query pair. So what you can see from this is that a user who knows data, who knows business rules but doesn't really have a lot of SQL background can, on fairly short order, start working with the tables and the columns and so forth to start to generate query pairs in that 80% range of query pairs where data is pretty much a pass-through. And so this illustrates our sort of our two-pronged approach to creating query pairs. For that 80% of straight pass-through query pairs, we've got the Query Wizard. And for the remainder, the 20% remainder, where more complexity exists in terms of the testing need, we've got the regular query pair editor. And this would require a user who has both data knowledge and business rule knowledge as well as SQL knowledge. Now that user, if they wanted to, could simply sit down and code up the query pairs from hand, or if they wanted to scaffold their query pairs using the data wizard and then modify those query pairs by hand, that's another convenient way of using the wizard to get a little greater productivity in terms of query pair production. So there's a two-pronged approach: the Query Wizard for the 80% of pass-through queries on average, and the Query Editor, I should say Query Pair Editor, for the remainder, with the option of including greater elaboration in the tests to create the full library of tests that you'll need for your testing. Let's move on and talk a little bit about scheduling now. In order to describe scheduling in QuerySurge for you, we need to introduce some new terms, and suite is a term that is used in many testing tools. I've just created a new one, and as you can see, it's an empty suite. It's just a collection of query pairs for purposes of execution. If I want to populate my suite with a folder from my design library, you can see I've got the folders on the far right of this page. All I have to do is drag and drop, and I've got all of those query pairs in that folder now available in this new suite. Now, if I wanted to, I could just save the suite and start testing. On the other hand, as frequently happens with testing cycles, you need a more customized set of query pairs to execute that doesn't necessarily match the original groupings that you did in design. So if I need to, I can edit out query pairs from the suite that I started with. In addition to that, I can drag in other folders if I want to. I can drag in individual query pairs should I need to. And once I've got the mix of query pairs that I want for this suite, all I have to do is save it, and I'm ready to roll. If I want to run, the easiest way to run is just a one-off run by right-clicking on my suite and asking to run now. But of course, that only satisfies a relatively small percentage of execution needs. We need more formal scheduling, and that's what we've got a scenario for. And a scenario is just a collection of suites. I'm just going to dump 3 of them in here, but it can take any number. And I can schedule these by calendrical scheduling. So for example, if I know that our environment has housekeeping that goes on at midnight, I can schedule around that very easily just by choosing convenient times for execution. And I can schedule as many suites as I want to in this manner in order to execute according to the calendar. Now, this kind of scheduling meets the needs of a lot of our users for their calendar-based scheduling needs, but many users have needs beyond that in terms of scheduling. And the other major category that we like to think in terms of is what we call event-based scheduling. And what that means is scheduling QuerySurge in response to events external to QuerySurge in the broader environment. And in order to do that, what we do is we use the QuerySurge Execution API. QuerySurge has a command line execution API that can give any external process access to its execution engine simply by calling through the command line. And there are 3 common use cases for this. One of those is to drive QuerySurge out of a scheduling tool. A lot of organizations have a commercial scheduler, or they want to set up QuerySurge and drive it out of a Windows schedule or a cron job on Linux. So you can use the execution API to schedule QuerySurge using any setup of that sort. So that's one common use case for the execution API. Another common use case is for continuous integration setup. So if you're doing continuous integration and you want to make QuerySurge part of the workflow of your continuous integration, again, you can use the command line execution API to do that. And the final common use case for the execution API is to drive QuerySurge out of your ETL tool. And I've got a little demo of that, so I'm going to go over to our Run dashboard and launch our little demo ETL here. And what you can see is that the ETL, which just has a couple of legs and is going to drive a small amount of data, is going to run through its paces, so to speak, on each leg. And at the end of each of those legs, it's going to call into QuerySurge via the API, and is going to execute tests against each leg individually. And you can set up your ETL like this, so regardless of how many legs you've got, as you process through the ETL, the data will get pushed through, then QuerySurge will execute on whatever data is relevant to the leg that was completed. And at the end of the whole process, not only will you have your ETL data to look at, but in addition to that, you'll have all the QuerySurge information to look at that will clue you in as to whether there are issues and where those issues might lie in your overall code base. We're coming up to the end of the first leg, and once the completion tasks are run on that leg, we'll see that the ETL is going to call into QuerySurge, and in the page behind this, we'll see the execution come up. And the second leg is continuing while the call into QuerySurge is made, and once that comes through, we'll be able to see the execution start. And now QuerySurge is queuing up that call, and we'll start to see query pairs get executed briefly. What the lower portion of this, the graphical representations are showing us are the different statuses of the query pairs in QuerySurge. Up on top, we can see progress. We can look at data as it's flowing into QuerySurge. So as long as any one query pair has completed, we can start to look at that data and evaluate what it might mean in terms of the testing. We don't have to wait until the whole set is completed. And let's go back while this is running, and we can see that the second leg is just completing now. And so we're going to have another call into QuerySurge for testing on that second leg. And we'll see that come up now, and we'll see a similar kind of set of tests execute and run against our ETL. Now, while we're waiting for everything to queue up and to start running there, I'm just going to cut over to another suite that I've prepared to show us some of the different categories of item that QuerySurge traps during execution. So what we're going to look at here is a query pair where we've got some flags, and these flags are there because we set up this query pair with shared keys between source and target. And QuerySurge was able to use those shared keys to compare the data, and it found rows that it has flagged, as you can see from the legend, as data failure rows. And those rows are flagged that way because QuerySurge found that they had like keys in source and target, but had different data, which of course is highlighted here. So that's one crucial piece of information that you need to know about each of your runs. Where are the rows matched, but where does the data disagree? I'll just mention parenthetically at this point that if I wanted to export any of this data, I can do that quite readily to either an Excel or a CSV or an XML format. So if I need to share this out with a coworker so that we can understand what the issues in the data are, I can very easily do that in Excel. If I need to export this to another tool for some sort of workup, I can use any of these three formats that is appropriate. So this is the example that I wanted to show you of a data failure. Let's look at another important category here, and this is something that also occurs quite regularly in ETL development and big data development. And you can see in this example, we've got in the upper right more rows coming back on target than on source by a count of 4. Those rows have been flagged with the yellow flag, which you can see by the legend is what we call a non-matching row in QuerySurge. And what a non-matching row is a row where QuerySurge looked at the keys between source and target and found that either on source or on target, the key for a row was unique to either source or target. In this case that we're looking at, QuerySurge found 4 rows with keys that were unique to target, so it flagged them with the yellow flag and the red outline to alert us to the fact that there are non-matching rows in this test that were returned. And again, we now have the job of sitting down, examining the data, looking to see whether this represents a bug in the ETL, perhaps a flaw in the test itself, whatever it might happen to be. All right, if we look back, we can see that our second leg has run in QuerySurge, and actually we did pretty good on this leg in terms of tests. They're all passing except for one. So we can go and, again, look at that data and start to understand what might be the issue there, very much in the same way that we've been talking about. Now let's go on and just move over to talk a little bit about reporting in QuerySurge. And what I'm going to do is choose to run one of our scenario detail reports. And that report gives us both a good high level as well as a very nice detail level view of each of our scenario executions. So let's look at the top part of the report here first, which kind of gives us that high level summary view of everything. And what you can see in the test results section of the report is the standard kinds of metrics that are associated with testing. The number of tests that ran, so we had 20 query pairs that executed, 40 queries, the number of tests that failed, number that passed, and from that we can calculate the pass rate, which is a not terribly impressive 70% here. Now that's not the full picture though, because we have other metrics that we present to you in the overview section that you can see at the bottom here. And some key metrics are showing right now. Let's just talk about those very quickly. First of all, you can see that this execution ran in about 6 minutes and 20 seconds. So we always want to be aware of timings in QuerySurge. In addition to that, right underneath that, you can see that we give you a verification count. And a verification for QuerySurge is each comparison that is done between source and target. So if you think of each of your source and target result sets as a table, and for each case you're going to be comparing cell 1.1 in source to cell 1.1 in target, cell 2.1 in source to cell 2.1 in target, and so forth. Each of those is a verification, and in this case we had about 6.7 million verifications. QuerySurge also tracks data failures, so we've got about 228,000 data failures, and with those two metrics, data failure and verification, we can count what we call the data reliability. We can calculate what we call the data reliability. And in this case, we're talking about 97% almost. What that means is that nearly 97% of our data came back comparing favorably. And that means that when we think of that number versus the 70% pass rate, that we can see that the data failures were sprinkled somewhat liberally, at least in relative terms, over a larger number of tests, as opposed to being focused into a smaller number of the total number of tests. So both the pass rate and the reliability are important for understanding exactly what happened during your execution. As you can see, we have a number of other metrics here in the overview, but I'm not going to drill into those. Instead, let's go down and look at the results section, the details section of this report. And what you can see here is that each of the query pairs that is executed is listed and has an outcome associated with it. So it's a very good at-a-glance view of what passed and what failed. In addition to that, we give you a number of metrics associated with the query pair level, so row counts and so forth for each query pair. But of course, for the day-to-day user, for the implementer, probably what they're mostly going to be interested in is what failed. And they're going to want to be able to look at the data for the failing items in their tests. And what I'm about to show you is drill down. You can drill down into any of these, your passing or your failing data. And when you click on any of the query pair names, you end up right back in the dashboard with the ability to look directly at the underlying data for either passing, failing, or other tests in QuerySurge. So it's a very nice melding of both the high-level reporting information to the lower-level granular data that is ultimately of interest in testing. Well, we've talked here about our reporting. I should mention before we kind of widen out the topic of reporting that any of these reports can be exported. In this example, you can see that we can save as a PDF, or we can export the data in the report in an Excel format. Pretty much all of the reports in QuerySurge have those options. Now let's think about reporting in a broader context for a moment. And that context is what we think of as team communications. And the formal reporting is one part of a sort of a tripart grouping of features in QuerySurge for team communication. It's probably in some ways the most obvious one. The second of those we've already seen. That's the widgets that we've already talked about. And again, they're real-time reports on where the project is at any given moment. And there's a third and final leg of this stool, so to speak, and that is the ability of QuerySurge to do email notifications. So QuerySurge can send out notifications for any tests that you want it to. The contents of the email is completely customizable by you. In addition to that, the triggers for the emails are customizable as well, so that if you wanted to send out an email every time a scenario ended, you could do that. But if you wanted to send out an email every time a scenario ended, only if there were failures in the scenario, you could set that up as well. So lots of good flexibility around email notifications, and it's the email notifications plus the formal reporting plus the widgets, the dashboard widgets that give you a full view across the team and possibly beyond even of how the QuerySurge project is going and what the details of it are at any given time. So it's those three features together that really comprise our team communication package within QuerySurge. All right, well, that's really our tour of QuerySurge at this point. I guess I'd just like to end up by kind of drawing the camera back and saying again that the whole point here is to be able to test data in bulk on each of your builds before you get to production, and then do thorough vetting of your release candidate prior to release to production, so that you get as good an outcome as possible before you go to production. I think we'll stop now, and we'll ask for questions.